Here's an example of graphing a transformed cosine graph. And I'll try to do this pretty quick. I explained the method a little bit before. Well, we first would get the period. Well, first let's write it as equals 5 cosine, and write it as a number times theta. And we're going to match that to the form a cosine b theta. And so a, let's do another math mode. A equals 5, and b equals 1/4. So the period, we have a memorized formula for that, and that is p equals 2 pi over b. So that's 2 pi over 1/4, or that's 8 pi. Okay, that's going to be crucial. The next thing we get is the quarter period. And the book basically does the things this way, but it doesn't lay it out quite as formulaically. I don't know. That's 2 pi. The reason that's useful is we will step by quarter periods, or 2 pi, as we graph in a minute, okay, to plot points. The amplitude is equal to just the absolute value of a. Well, a isn't negative. Maybe we'll switch a to negative at the end and see what happens. And that's just 5. Okay. Now we're ready to go. Well, actually, one more thing. The anchor point for a cosine, that's the start of the cycle. For the sine, it starts in the middle. And if you haven't shifted at all, it's the origin. For a cosine, it starts high, and so we're going to take 0, theta equals 0, and it's going to start high. Well, it doesn't start at 1 because we multiplied the cosine by 5, or it's going to start at 5. So that amplitude is coming in right at the start. Okay, so actually let me put that. That's our first point to plot, our anchor. Then we step up by quarter periods. Okay, a quarter way through the cycle, if this was starting high, then the next point, if we think about a cosine or sine graph, it's back to the middle. And so that's going to be 0, because there's been no shifting vertically. Next, I skip up to the next quarter period point. I'm just increasing by increments of 2 pi each time. Now this is going to be the low point, and so we go down to minus the amplitude, minus 5. Now, we're 3/4 of the way through. We go back to middle, which is 0. And then we finish out the period 8 pi. You should check that as you finish out the cycle, you should be getting to the full period. That's back to the top, because that's how cosine starts a period or ends a period, back to high. Okay, so we can just plot those points. Let me plot them exactly. I'll cheat a little bit. You'd be doing this by hand usually. 0, 5, plot, and then, 2 pi. I wonder if we can do, I don't know how to enter pi on this, so I'm not going to worry about it. 0, plot, 4 times, it's, 3.14 is close enough for plotting purposes, minus 5, 6 times 3.14. So on the calculator, of course, you could just put in pi, and of course, mostly we're doing this by hand. 6 pi, and then 8 times 3.14, and 5. Okay. So there's some points that are plotted, and then we're just going to freehand in between those and make a nice graph. I'll go ahead and let the calculator or the computer do that in a minute. But then what else? What would we like to do? We usually are asked to do 2 periods to sort of illustrate the repetitive nature of the thing. So we could do one of 2 things, or maybe more. We could step backwards from 0. We could actually go from 8 pi up to 16 pi if we wanted, but I've already got the window from minus 8 pi to 8 pi. So we could step backwards. Just start stepping backwards from this anchor. Minus 2 pi. High goes to middle, so that's 0. And then keep stepping backwards. And that's going to be low. High, middle, then down to low. An even faster way to do it is to recognize that cosine is even. That's why we get the same numbers. Like for 4 pi and minus 4 pi, we get minus 5. For 2 pi and minus 2 pi, we get the same numbers. That's because it's an even function. So that's very easy. We just reflect across the axis. So that means we're going to get some various other values. I think I'll skip plotting those by hand. But we could just plot these values to get a graph that goes in here. And let's go ahead and try this out, see if it works. 5 cosine. Here's the proof of the pudding. Did I set stuff up right, or did I... and I'll just put in x here because it likes x better than theta. X over 4. Yes. Very good. It thinks, hey, do you want degrees or radians? And of course I want radians mode. And there we go. That's what it's going to look like. So you're going to plot these points and then maybe these points as well, and just connect them with some sort of nice smooth sinusoidal curve. Okay.